After endless research and development, the team at Tiger Lifting came up with the patent-protected quad-cam pole system. As you can see, the back end of the pole pushes the front end of the pole back into the ratchet gear. They are designed to reciprocate with each other so that at least one of the poles is constantly engaged with the ratchet at any one point. There is a minimum clearance of the poles over the teeth of the ratchet gear, which eliminates the chance of pole bounce. As I am showing in the video, even without springs, the poles are forced back into the ratchet gear, along with our upgraded pinion shaft, which increases brake efficiency. The quad-cam pole system allows Tiger to certify the Tiger Professional and Specialist chain blocks for fitting or cross-hauling up to 60 degrees with no deration. Here we see the traditional teardrop poles, which are both spring operated. As you can see, the poles engage with the ratchet gear in sync. However, when I move the ratchet gear to this position, we now have no engagement of the poles, which puts the brake in a very weak position. Another failure mode is pole bounce. This would occur when the hoist is subject to shock load, which could bounce the pole out of the ratchet gear. We can see evidence of pole bounce from marks within the brake cover. The most common failure mode, especially for hoists being used in harsh environments, would be spring failure. Corrosion to the springs over time could cause them to fracture, and because the traditional teardrop poles are reliant on springs, a failure to the spring could cause a brake to fail, as shown in this video. Without springs, these systems rely on gravity keeping the poles engaged and are flawed when the hoist is used at angles away from the vertical.